Okay, let's look at what it is we're trying to accomplish. Then we'll look at the graphs that we have and explain those. And then we'll dive directly into the calculus and derive what it is we're being asked to derive. So, derive the formula for the volume of a sphere of radius r. In the right-hand corner, I have a nice two-dimensional picture of a semicircle. The equation of this semicircle is y is equal to the square root of r squared minus x squared. And what I've done is I've made 15 slices through the semicircle. Now these slices are going to represent lines that will be revolved around the x-axis as a nice representation. And so those slices are actually the radii of the various circles that I'm going to get when I revolve the entire semicircle around the x-axis. So let's go ahead and let's look at that, see what we get. So here I'm revolving the semicircle around the x-axis, and we can see that when we revolve it in one full revolution, we get an entire sphere. Now the integral is going to add up infinitely many of these. I've only made 15 slices. The integral is going to add up infinitely many of these radii, and we're going to use these radii as if they were full circles. So the value of y equals the square root of r squared minus x squared, actually serves as a radius function. So my radius function of x is the square root of r squared minus x squared, where each of these line segments represents the radius of some kind of circle. Now we know that the area of a circle is pi r squared. So we're going to treat these as if we have fully rotated them or revolved them around the x-axis so that we do have a complete circle. So if I take the integral from negative r to positive r of pi times the square of the radius function, this becomes the integral of negative r to r of pi times the square of the square root of r squared minus x squared, which simplifies, and we find the antiderivative, which is r squared x minus 1/3 x cubed, all times pi. Evaluating this from negative r to r, as you work it out, you will end up with 4/3 pi r cubed. And if you open your web browser and type in volume of a sphere, you will get 4/3 pi r cubed. God bless you, wherever you are today.